On Rick's suggestion, I thought I'd put together a series of tutorials on distinguishing biofilms from decalcifying dentin. So this is the first part in a series of tutorials that hopefully can help you with this question. So let's start with a simple question. The question is, if all the predentin and smear layer were missing, what would we observe? And the answer is, it depends. What does it depend on? Well, it depends on the type of dentin. Is it sclerotic dentin, irritation dentin, primary dentin, secondary dentin? It also depends on the location of the dentin. Dentin is different coronally than midroot than apically. It depends on the age of the dentin because the dentin is a function of the odontoblast, and the odontoblast ages and changes with time. It depends on the status of the dentin prior to your intervention. And typically, you don't know that status. We have no way of looking into the tooth and examining it prior to our intervention. And lastly, but not least, it depends on the bias of the investigator, because the investigator can just pick certain areas, and it can be very difficult to really detect the bias of the investigator. So location, age, pre-op condition, and bias all affect imaging interpretation. The age of the dentin depends on the age of the odontoblast. And adult dentin looks different than young dentin. And it's important to understand what those differences might be. So to re-ask the question, if all predentin and smear layer would be missing, what might we observe? That's what we should ask. What might we observe given the many different conditions that may be present? So to examine more closely, let's pretend that we're looking at the mineralization front right where that square is. And all of the predentin other than in that square is gone. What would we actually see? And if you're in relatively young dentin in the coronal part, this is what you'll actually see. You'll see this globular dentin. And what you're really seeing here is you're seeing all the missing parts of the proteoglycans and non-collagenous proteins that are part of the predentin that are missing. They're missing on account of the specimen preparation techniques utilized. So you're looking at this globular dentin. For example, if you look at my arrow here, you're looking north at that mineralization front, right at the level where the predentin is partially calcified. And the predentin south of that is gone. So if you look apically, let's look in this little square area here. The dentin has a completely different look. And here you're looking at the mineralization of the predentin, and it's partially mineralized. So you want to gain some pattern recognition on what partially mineralized predentin looks like, because it can mimic biofilms. So there you can see that this is a calcospherite of predentin, and you can see the mineralization front, what that looks like. So fully mineralized predentin, before it becomes actual dentin, has that melted cheese look to it, very much like biofilm EPS. So you want to develop your pattern recognition in other areas of the predentin that's in the process of mineralizing. So it's good to develop your pattern recognition for predentin that's in the process of being mineralized. So when predentin or collagen mineralizes, it mineralizes with an EPS-like material, which looks like melted cheese. So you need to know how to identify this. You can see the collagen, and now you kind of know what's happening. You can see the collagen substructure. You can see the mineralization taking place, or perhaps it's demineralization. You don't actually know which in this kind of samples that we look at So now you have a little better recognition of what you're seeing, And now when you look at a different condition of dentin, here you can see you get a sense for the collagen, but look in the tubules. You can see the collagenous structure of the tubules. They've been demineralized enough that you can see the collagen of the intertubular dentin because the peritubular dentin is missing. You can see the collagen structure. So this tells you something about the demineralization that's taken place. The peritubular dentin is non-collagenous dentin. So if you can see the collagenous nature inside the dentinal tubule, you'll know that it's been demineralized significantly. As this picture shows, there's been significant demineralization that goes on here. You can see the collagen structure within the tubule, very little predentin showing, and you know that the peritubular dentin is completely missing. As it is in this picture, you can see all the predentin is going. You're looking at the mineralization front, and you can see how the dentin is kind of eroded away in labors. Now, we know from the prior tutorial that peritubular dentin is non-collagenous mineralized tissue. There's no collagen in this tissue. It's the first tissue to be demineralized, and it's demineralized much easier than intertubular dentin. It's usually from the restorative literature, it's demineralized down about four microns into the tubule. There you can see the peritubular dentin that hasn't been demineralized. So when you're looking at the axial view, the level of demineralization of the peritubular dentin can give you a hint on how much demineralization has taken place. For example, in this picture, you can see you cannot see the collagenous structure of the tubule. So the peritubular dentin is still present here. You get no sense that there's collagen fibers within the tubule. And similarly here, you're looking at the mineralization front. There's no predentin present, but the collagenous nature of the tubule is not seen. If you remember from our tutorial, that peritubular dentin is almost like a sheath around the odontoblastic process, and it's non-collagenous in nature. Here's one of Captain Kirk's cases. So it presents a very confusing picture because it's been obturated. So there's obturation materials, there's sealer, there's dentinal debris. But every so often, you'll get a look at the naked dentinal wall, and there you can see there's a little bit of predentin, calcified tissue. Perhaps that's a little bit of a smear layer there. And then when you go in and actually look at the tubules, this was a general wave case, I believe, and you can see the peritubular dentin is still present. There's a lot of contents in the dentinal tubule. In another look, in a different area, you get a completely different conception. And then when you look at the tubules very closely, you can see that the peritubular dentin contents are still there. And when you look even closer, you can see the mineralization of those contents gives an appearance almost of a biofilm, that melted cheese look. Now, these are not organisms. This is the non-collagenous material of the peritubular dentin, and it can mimic what looks like a biofilm. And just to tease you with another example, this is Captain Kirk's same case apically. When you go in and look at the terminal part of it, you have a lot of sealer present a lot of debris, but you usually get a chance to look at the mineralization front. And when you look at this, the future tutorials will show you how to identify this not as decalcifying predentin, but as bacterial biofilms. So these are actually bacterial biofilms present on top of the mineralization front, as opposed to this, which looks like a bacterial, but it is just demineralizing predentin. So future tutorials will hopefully help you become a little more sophisticated in evaluating these images. So I hope this tutorial was a little bit helpful.